Hello. So, this is a series to help the students who have just got into class 11th and they require some mathematical background for physics. So, as you can see, the name of the series is Mathematics Required for Physics in Class 11th. So, let's start with our first topic, that is angle in radians. So what is angle in radians? So we all know about angle in degrees. So we all know what is 180 degree. We all know what is 60 degrees. So radian is just another unit. So for example, we have seen length ka measurement in our previous classes. Maybe I can say that this length is 10 centimeter, or I can say this is zero point 0.1 meter. But in any scale, this is the same length. So we have conversion for them. For example, I can say 1 meter is same as 100 centimeters. Or all of you already know also कि 1 centimeter is also equal to 10 millimeter. So this length is also equal to 100 millimeter. So what I'm trying to say is we can change this number and this dimension, but we are talking about is the same dimension, the same length. So this number and this dimension together tells you the whole picture, right? So if I say 60 degrees or some radians, so maybe they are same because let's see. So first of all, we need to write down the formula how to convert the angle to radians. So the formula goes like this. Angle in radians is equal to pi by 180 into angle in degrees. So for example, 60 degree, if you want to find the angle in radians, will be pi by 180 times 60, and that will be pi by 3. But a simple conversion that you may remember is that pi is same as 180, and you can also use, so this side is in radians and this side is in degrees, and what you can also use is the unitary method. So for example, I say what calculate the value of 90 degree, you can divide this side by 2 and then you can divide this side by 2 also. So this is pi by 2. So you will just look at this equation. So for example, I say find the value of 30 degree. Okay, I can divide this value by 6. 180 degree divided by 6 is 30 degree. So I will divide this side by 6 also. So in this way, you can use unitary method also. But angle from degrees to radians can be converted very easily using this formula or the unitary method. So let's write down some standard values. So let's write down pi by 6, it is same as 30 degrees. Pi by 4, it is same as 45 degree. Pi by 3, so I should write equivalent sign. It is, so this angle is in radians and this is equivalent to 60 degree. Pi by 2 is equivalent to 90 degrees. So for example, I say what is the value of 120 degree. So this equation might be a little difficult for that. So what you can do is just multiply by pi by 180. So you will find 2 pi by 3 is the angle in radians. This is a conversion for 120 degree, for example. Okay. Now what was the use of this? What was the use of defining the angle in radians instead of degrees? We will say कि हमें अच्छा खासा degrees पता था, why are we defining in radians? So, and that is because it makes the formula of the arc length easy. So everybody knows for a circle the circumference is 2 pi r, and since pi is 180, same as, so 2 pi is equivalent to 360 degrees, 2 pi radians, so it is like 2 pi into r. So that says something. Let's look more carefully into the let's look more carefully into the length of a sector. Let's look into this length. So let's say this length radius is r, this radius is r, and this angle is theta. From class 10th, let's say this theta is in degrees for now. So from class 10th, you know theta, the length of this sector, it is some multiple of 2 pi r. And what is that multiple? It is multiplied by theta by 360. Correct? So what is the angle subtended and divide by 360? This is in degrees. So let's look at it more carefully. Theta in degrees, I cancel this 2 divided by 180 into pi into r. Let's look into these numbers. So pi by 180 into theta into degrees is the theta in radians into r. So length of this sector now has a very easy formula. Now we can say it is equal to theta, which is in radians, into r. So for example, if I say find the length of this arc, where this is 45 degree and this side is 3 units. So you can use the large formula from the class 10th. So, but I will use the short formula that we just wrote down now. Theta in radians into r. So theta in degrees we have as 45 degrees. So theta in radians will be pi by 180 into 45, and that is equal to pi by 4. We all remember theta 45 degree was pi by 4. So the length of this arc is by definition theta, let's say theta in radians into the length into the radius r, and that is pi by 4 into 3. So it is 3 pi by 4 units. Yep. So you can put the value of pi, which is approximately 3.14, and find the exact result. And you can check from class 10th also that if you solve with the class 10th formula, you will have got the same result. 45 degree divided by 360 into 2 into pi into 3. So 2, 180 and 1 and 4, and we have 3 pi by 4 units. Okay. Well, that makes life easy. Now let's look also into the area of the sector. So it also makes the formula of the area of the sector also very easy. So what is the area of this sector? From class 10th, we know it is theta by 360, and where theta is in degrees, into pi r square. And let's see, I can say half times theta in degrees into pi by 180. I separated this term into r square, and this is half theta in radians into r square. So for example, let's do this time for a 60 degree arc of radius 7 maybe, and let's say we will also use pi approximately equal to 22 by 7. Let's not do that, let's not put the values in, but let's see. if the area of this sector will be, by new definition, it is half into theta in radians. So theta in degrees is 60 degree, and theta in radians, this time I will write directly pi by 3. So it is half theta in radians, which is pi by 3, into radius square into 7 square, which is 49 pi by 6 square units. And you can calculate this answer from your class 10th formula also. So this time I use this formula, half theta into radians, theta in radians into r square, and you can use here this formula also. You can say 60 degree by 360 into pi into 7 square for my given diagram, 7 7 60 degree area. So 1/6, and that is 49 pi by 6. Did we made a mistake here? Oh yeah, sorry, this is also 6. I'm sorry, this is 2 into 3, 6. So we got the same answer, right? Hopefully you enjoyed this lecture. Make sure to like, share and subscribe.